Okay guys, Common Core Algebra 2, so we're now looking at, this is actually section 3.2 and it's about solving systems. So we looked at graphing in 3.1 and now we're going to look at substitution. Next lesson is going to be about elimination, and then finally we'll end with something called matrices, which we're going to use our calculators for again. So to solve a system by substitution is what we're going to look at today. Again, this is something you saw in Algebra 1, and a quick reminder, if we want to check a point is a solution. So we've got this point, and remember every point is going to have an x and a y value. So we're going to plug this in. It has to be true for both equations. Don't forget, we have to make a true statement. So we plug in 8, and then we're going to have 3 times 6 plus 2, and if we try to simplify this, we get 3 times 6 is 18 plus 2. That tells us that 8 equals 20, which you can see is not a solution. So we would say that no, this one is not a solution. Remember, if this had been true, we would then also have to plug into the second one and test that point, which it may or may not be true for that one. Okay, so big thing there, plug in your x and y values and just trying to simplify one side or both sides to see if we come up with a true statement. Since 8 does not equal 20, it is not a solution. And to solve a system of equations, we're going to have 3 steps. So the first one goes back to something we looked at in the first chapter, which was solve one equation for one of the variables. It doesn't matter which variable we solve for, but it's usually going to be easiest if one variable has a coefficient of 1 or negative 1. That's the one you want to try to solve for. Okay, again, it doesn't matter which equation you choose, and it doesn't matter which variable you solve for. Just try to find the one that's going to take the fewest steps to solve that equation for one variable. After we do that, the next big thing, so we're going to solve, then we're going to substitute the expression from step 1 into the other equation and solve for the remaining variable. So after we substitute that expression in, there will only be one variable left in that equation, and we're going to solve for that variable. And then finally you're going to get a value. So this step 1 is going to give us some expression. Step 2 is going to give us like x equals some number or y equals some number. And then we're going to take that value from step 2 and we're going to substitute and solve again. So the big thing, solve, substitute, and solve. And what that would look like, you see here I have an example with a system of equations, 2 equations. We want to start by solving one of our equations, remember. In this case, if I look at this equation, this is not the easier one to solve, but my second one is actually the easier one to solve because this y is by itself. It's only going to take one step, and what we're going to do is subtract 2x from both sides, and I'm going to write that. A lot of people may write that as 6 minus 2x, which is perfectly fine, or you can say y equals negative 2 plus x. So we have y equal to some expression, and that's what we want. What we're going to do with that expression then is the start of step 2, we're going to substitute that expression from step 1 into the other equation. So it's really important you're writing down all these notes. So in this other equation, since y equals a negative 2x, I'm going to take that and I'm going to plug that in for y. And you'll notice here when I write that, the only thing that's different now, I've kept this whole equation, the only thing I've changed is that y value has become negative 2x plus 6. I still have the 2x plus, I still have that coefficient of 2. I changed the y to negative 2x plus 6, and it still equals 8. And you'll see here, we're going to solve this now. We only have one variable left. So by combining, or we're going to distribute that 2 first. Okay, so you can do this part on your own. You're going to distribute the 2, and then you can combine like terms and finish solving for x. This step now is nothing new for us. You guys have solved a million equations in your math careers, and so if we did that, we'd solve for 2, and we should end up with x equals 2, and that would give us that solution. Okay, x equals 2. Now remember, there's an x and a y value that we have to have. So we've solved for one equation, we substituted that expression in, then we solved for the remaining variable, x equals 2 is part of it. Now we're going to do that substitute and solve piece again. So I want to substitute this into either equation, but really it's easiest to substitute into this equation where we have y equals, because we're not going to have any solving then, we're only going to have some simplification. So I took my x equals 2 now, and I'm going to substitute that back in there, you see nothing else has changed. We kept the y, the equals, -2, change my x to 2, plus 6, and I can multiply -2 times 2 and then add 6, and I actually get, in this case, that y equals 2 as well. So those two pieces are your solution. We write them as an ordered pair, just like our point of intersection from the last unit. So our solution is 2, 2. Now, it's not always that x and y are both going to be 2, it's just a coincidence for this problem. Okay, so there were 3 steps. Really, you could break those steps down even more. You're going to solve for an equation in step 1. Then you're going to substitute that expression and solve for the other or only remaining equation in step 2. And then you're going to substitute and solve again in step 3. Okay, those are your big things. So solve, substitute, solve. And then you'll be done. You'll have your point, which is the same if you think about last section, the point of intersection or your solution. It makes both equations true. We'll see you next time.